Okay, so good morning everyone. Today we'll be looking at section 2.5 factorization of polynomials. Okay, so before we learn about factorization, let us first look at what do we mean by a factor. Consider the number 18. So 18 can be written as 2 times 9 or 2 into 9. So we say 18 is a multiple of 2. So if 18 is a multiple of 2, we can say 2 is a factor of 18. Okay, in the same way we can say 18 is a multiple of 9. So if 18 is a multiple of 9, we can say 9 is a factor of 18. So another thing that we notice is 9 divided by 18, we get 2 times 9, 0, the remainder is 0. Again 18 divided by 2, so 9 times 2 is 18, the remainder is 0. So when I say 2 is a factor of 18, okay, when 18 is divided by 2, the remainder is 0 and 18 is a multiple of 2. So if any one of these three things is true, the other two is also true. Okay, if I say 18 is a multiple of 2, or let's say if I say 18 is a 9 is a factor of 18, then we automatically mean some number into 9 is 18. That is 18 is a multiple of 9. And also, since this is a multiple of 9, when that 18 is divided by 9, we'll get a remainder 0. Okay, so if a number is a factor of, let's say, number 18, we also mean 18 is a multiple of that number, and when we divide 18 by that number, the remainder is 0. Okay, so this is what we mean by a factor. So a factor is some number that divides the original number perfectly, that is the remainder will be 0. Or another way of saying it is, it is a the bigger number is a multiple of the factor, or some number times the factor will give us the bigger number, or the bigger number is a multiple of the factor. Okay, so I hope you understood what do you mean by a factor. Okay, now let's move on. Now let us look at factors of polynomials. So before in the previous slide we saw factors of whole numbers or integers. Now let us look at factors of polynomials. So consider the polynomial 2x plus 6. So we can write this as 2 into x plus 3, or 2 times x plus 3. So what do we say? We can say 2x plus 6 is a multiple of x plus 3. So because 2x plus 6 is a multiple of x plus 3, we can say x plus 3 is a factor of 2x plus 6. Okay, just like we saw in the previous slide, because 18 is a multiple of 2, we can say 2 is a factor of 18. So in the same way, since 2x plus 6 is a multiple of x plus 3, we can say x plus 3 is a factor of 2x plus 6. Also, when I divide x plus 2x plus 6 by x plus 3, 2 times x plus 3 is 2x plus 6 and the remainder is 0. So if I take this 2x plus 6, so when I say x plus 3 is a factor of 2x plus 6, I also mean when x plus 3 is divided by when 2x plus 6 is divided by x plus 3, the remainder is 0, and 2x plus 6 is a multiple of x plus 3. So just like we saw in the case of integers, all the properties of factors, that is, when I say a number is factor, I mean it is a multiple of the bigger number is a multiple of that factor, and when I divide that number by the factor, the remainder is 0. All those three properties are true for polynomials also. Okay, so I hope you understood what do you mean by a factor of a polynomial. So check whether x plus 5 is a factor of 3x plus 15. Okay, so when if I know that x plus 5 is a factor of 3x plus 15, okay, this would mean when 3x plus 15 is divided by x plus 5, the remainder is 0. Okay, because see, if x plus 3 is a factor of 2x plus 16, what is also true? 2x plus 6, when it is divided by x plus 3, the remainder is 0. So if I want to check when if whether x plus 5 is a factor of 3x plus 15, what I have all I have to do is, if this is true, the when I divide 3x plus 15 by x plus 5, the remainder has to be 0. So to check if this is true, all I have to do is I have to check whether this is true, because if this is true, this will be true. If this is false, this will also be false. Okay, so to check what the remainder is, we have what we studied in the last class, the remainder theorem. So in the last class we solved examples like this: find the remainder when a polynomial is divided by a linear polynomial. Okay, so what we have to do, all we have to do was we had to find the 0 of that linear polynomial. So here the 0 is 1, and substitute p of 1 in the bigger polynomial to get the remainder. Okay, I hope you remember the remainder theorem from the last class. Okay, so so we are interested in finding whether the remainder is 0 when 3x plus 5 is divided by x plus 15. Okay, now the remainder theorem tells us how we can find this remainder easily. So how do we do that? We have to look at the 0 of the divisor. Okay, so the 0 of the divisor here is x plus 5, and the 0 of the divisor is minus 5. So instead of p of x is equal to 3x plus 15, in the place of x I substitute p of minus 5. So p of minus 5 is 3 times 3 times this is 5. Okay, this is 5. 3 times minus 5 plus 15 minus 15 plus 15 is 0. So the remainder when 3x plus 15 is divided by x plus 5, the remainder is 0. Because the remainder is 0, what can we say? X plus 5 is a factor of 3x plus 15. Okay, so I hope you understood what we did here. First thing that we know is we are asked to check whether x plus 5 is a factor of 3x plus 15. So what do we know? We know if x plus 5 is a factor of 3x plus 15, when I divide 3x plus 15 by x plus 5, the remainder has to become 0. So I am checking whether the remainder is 0. How do I check whether the remainder is 0? I use the remainder theorem. What does the remainder theorem tell us? When I divide a bigger polynomial by a linear polynomial, to find the remainder, I have to find the 0 of the divisor. Now here the 0 is minus 5, and substitute that value in the place of x in the bigger polynomial or the dividend to find out what the remainder will be. So here when I substitute in the place of x by minus 5, I get the value as 0, which means the remainder is 0. Because the remainder is 0, what does this tell? X plus 5 is a factor of 3x plus 15. So if this if suppose we got the value as some 3 or negative 20, then what does it mean? Since the remainder is not 0, we can say x plus 5 will not be a factor of 3x plus 15. Okay, so I hope you understood that part. Okay, so we saw x plus 5 is a factor of 3x plus 15, and by this we can check. To check this, all we need to do is check whether the remainder is 0. Now the remainder theorem tells us to check whether the remainder is 0, all we have to do is find the 0 of the divisor and substitute that value in the place of x in the bigger polynomial. Okay. So to check whether x plus 5 is a factor of 3x plus 15, all I have to do is find the 0 of that x plus 5 and substitute it back in the place of 3x plus 15. So this brings us to a theorem called as the factor theorem. So what the factor theorem tells us is, so if I have a polynomial p of x of degree n greater than or equal to 1 and a is a real number, okay, just like in our previous example, I am taking a polynomial, okay, p of x of degree greater than or equal to 1 and I have a real number a, okay, I have a real number a, then x minus a is a factor of p of x if p of a is equal to 0. Okay, so what we have done here, we have written it in the form of a theorem. Okay, so this is our x minus a, okay, and this is our p of x. So if this x minus a, okay, consider this x minus a is a factor of this p of x, what do I have, what should be true? P of a, okay, p of a must be equal to 0. So here x minus a, so here minus a is minus 5, okay, so here a is minus 5, okay, so since p of a is equal to 0, this x minus a is a factor of this p of x. Okay, so in the previous example we have used p of x as 3x plus 5, and in the place of x minus a we have used x plus 5. Okay, so if p of a is equal to 0, then x minus a is a factor of p of x, and if if x minus a is a factor of p of x, p of a will be equal to 0. Okay, so I hope you understood. So the thing is, if I have a linear polynomial, okay, let's say instead of this x plus 5, suppose there is x minus 7, and here there is something, let's say 2x plus 2x minus 14. Okay, so if I have to say this x minus 7 is a factor of this p of x, all I have to do is substitute p of a equal to 7. So whatever value is here, okay, I have to take the negative of that because we are finding the 0. Okay, you take the negative of that, substitute it in the polynomial p of x. If we find that to be, that is that p of a to be 0, then this x minus a will be a factor of the p of x. If x minus a is a factor of p of x, then this p of a has to be 0. Okay, just like what we saw here, x plus 5 is a factor of p of x, that means p of negative 5 will be 0. If p of negative 5 will be 0, then x minus that whatever is inside that, so minus of minus 5 will be plus 5, so x plus 5 will be a factor of p of x. Okay, so I hope we are clear till there. Okay, let's move on.